For my third project, I'm going to prove that there is a buoyancy force. I am first going to use the buoyancy force formula where the force of buoyancy is equal to the specific weight times the volume of the displaced liquid. Then I'm going to use a free body diagram on the can suspended in the water and sum the forces in the y direction and solve for the buoyancy force. If my calculations are correct, then the buoyancy force found in the buoyant force equation and in the sum of the forces should be equal or very close to being equal. So here's my setup. I have a pot filled with water and a can that is totally submerged but not touching the bottom since it is being suspended by a string attached to a scale. The setup around the pot is used to make sure that there are no other forces on the can. First, I'm going to start with the buoyant force formula. Known and measured values are the specific weight of water equal to 9,800 Newton per meter cubed. I found the height of the can to be 11.5 centimeters and converted it to be 0.115 meters. The radius of the can is equal to the diameter divided by 2. I found the diameter to be equal to 8.5 centimeters, divided that by 2, and it came out to be 4.25 centimeters, which is then converted to 0.0425 meters. Now to begin solving, we know that the buoyant force is equal to the specific weight of the liquid the object is submerged in times the volume of the displaced liquid, which is just the volume of the can since it is totally submerged. I plugged in the specific weight of the water, then used the volume of a cylinder formula, which is pi times radius squared times height, and then plugged in the numbers and got the buoyant force equal to 6.39516 newtons. Now for the sum of the forces on the can, known and measured values are the tension in the string, which is equal to 0.05 newtons. The mass of the can is equal to 650 grams or 0.658 kilograms. And we know that gravity is equal to 9.81 meter per second squared. We first start with a free body diagram. Since the object is submerged in the water, it has a force of buoyancy going in the positive y direction. It also has a tension force going in the positive y direction since I have a string attached to the top pulling it up. And finally, it has a downward force, which is just the weight of the can. To solve the sum of the forces in the y direction, we have the buoyant force plus tension equal to the weight. We solve for the buoyant force, plug in the numbers, and we get the buoyant force equal to 6.40498 newtons. To conclude this project, we check to see if the two buoyant forces found are equal. We have 6.39516 is not quite equal to 6.40498. This gives us an error of 0.00982 newtons. I think this error is small enough to call this project a success. Reasons for this error could be small inaccuracies in the scales, measurements not being precise enough, and water specific weight being a little off since it is not pure water. Thank you.